All right, so we are finishing up our second day of review. We're starting on our 5th page. And I need to pull in. So on number 14, what do we need to recognize? That this is a graph of the derivative. So we need to change from our thinking about the graph of the original function to a graph of the first derivative. Find the following points and intervals for the original function. The maximum points at x. So how do we find a maximum for the original function giving a graph of the first derivative? Well, a maximum in the graph occurs where the first derivative is equal to 0. So we want, where is this equal to 0? And that is at, and we want maximum, so maximums have to occur at hang on a second. So there has to be a maximum point at two, right?
Yes.
Minimum has to be at -2. Why is this one positive and this one negative? Right, so again, we have to consider, this is the sign of the slope. So this is the positive slope, this is a negative slope. And so as we go from negative to positive, right, then what's our original graph doing? Right, we're going from a negative slope to a positive slope. That means it has to be a minimum. So -2 is a minimum. We'll come back and talk about 0 in a second. At 2, we're going from a positive slope to a negative slope. Positive slope to negative slope is a maximum. So 2 is a maximum, -2 is a minimum. How come 0 is not a max or a min? It's not crossing over from positive to negative or negative to positive. So where are the increasing intervals? Well, the slope is increasing where the first derivative is positive. Where are we positive from? I'll take that, -2 to 0. I'm not sure how your college professor would make you do this. -2 to 0, union 0 to 2. I'm not sure if they would take off for that or not. So I'm gonna go ahead and leave that as a 0 because technically at the point of inflection, it doesn't have a slope. Actually has a slope of 0. Decreasing interval, that's where the slope is. That is questions? Concavity. Now we're looking at a graph of the first derivative. We're concave up where the first derivative is what? Positive. So where is the, that's not right. Where the slope is positive, yes. So where the slope is positive, that's right. So where is the slope positive, right? Increasing is another way to say that. Where are we increasing? We're increasing from and where else are we increasing from? Where are we concave down? That's where the first derivative is negative or decreasing. And that is from and points of inflection. Question. Why is it a point of inflection? Because it's not going from negative to positive or positive to negative. Sketch a possible graph for number 14. So here's our coordinate plane. So we know at, what happens? We know at 2, we have to have a maximum. We don't know where that maximum occurs, but there has to be a maximum at 2. So I'm just going to pick a place. There's our maximum. We know at -2, there has to be a minimum. So I don't know where that occurs. We'll just put a point down there. Then we know at 0, there has to be a point of inflection. Usually that, if that's there, it's going to be 0, 0. We also know we are concave up from to -1. So I'm going to kind of just put a little dot there for our change. We're changing from concave up to concave down. And then same thing, we're switching at 1. So what do we have here? We know we are, so let's go from left to right. So from negative infinity to -2, we are decreasing, and that's also concave up. So that means we have to, should look like the bottom of a parabola. And that concave up continues to -1. Then at -1, we're switching to concave down, and that stops at 0. Now we're going to switch our concavity again back to concave. So now we're curving back up again. And now from 1 to infinity, we're concave down with a maximum at 2. So there's our possible graph of what that might look like. Yes.
1 and -1 have been part of the function.
Right, so to get concavity, right? Concavity is determined where the first derivative has a slope equal to 0. We're equal to 0 at, on the first derivative of -1 and 0. So I did miss those. Yes, thank you. -1 and 1. So that was our points of inflection. Yep. All right, points of inflection is where the first derivative, f prime of x, is equal to 0. And that was at -1, 0, and 1. Thank you. Because first, the slope of the first derivative is 0 at 0, meaning it's the point of inflection.
You also could say, like, on the graph of the first derivative, any max or mins would be a point of inflection, right? That's how you find it.
Max and mins of the first derivative is a point of inflection, yes.
Like the max and mins of this function.
Of the first derivative will be a point of inflection.
Okay.
Any other questions? Takes us to number 16, applications, right? Physics started this all, physics ends this, doing real physics. If the height in feet of an object is given by this function, find A, the average rate of change. How do we find the average rate of change? That is delta y over delta x. So therefore, we want the ordered pairs, and we're going to call this t. So we want the t1 and t2. So we want our time. So we want to find those ordered pairs. And so we're going to plug in, we get points, so we have ordered pair t and h of t. So if we plug in 0.5 into our function, what number do we get back out? We get 6. We plug in 1.5 into our function, what do we get back out? 7. And find the average rate of change. That means just we're going to use what? Slope formula. So slope is delta y over delta x. And that is 7 minus 6 over 1.5 minus 1, which is 1 over 1, which is 1 what? Feet per second. Now we want the instantaneous rate of change at 2 seconds. What's instantaneous rate of change? That is the first derivative. H prime of t is and we want to evaluate that for h prime of 2. I'm sorry, what?
1.5 minus 0.5 under A.
H prime of 2 then is -4 times 2 plus 5. Negative 8 plus 5 is? That's negative 3 what? Second. How do we find the acceleration? Acceleration is? That is, and that's negative 4 seconds squared. Questions? Concludes chapter 5.
Does the seconds have to be squared or does it matter?
It has to be the seconds that are squared, feet per second. Questions? That takes us to number 10. Now we're switching. Nope, it doesn't. We got to turn the page. That takes us to number 17. Now we move to integration. Evaluate or integrate the following integrals. So here we have an indefinite integral. That's just reverse antiderivative, right? Reverse derivative. And so that's going to be, we're going to add 1 to the exponent, is x to the 5th, divide by 5. Whatever exponent we go to, we divide by that same number, minus 3x to the cubed. And we're going to divide by that exponent is minus 3. The number just gets a x, and we have to remember to include plus c. Now we can come back and simplify. 5's cancel, 3's cancel. X to the 5th minus x cubed plus 7x plus c. Now we can calculate the definite integral. Here it gets a little bit complicated, so we need to use a method of integration. Here we're going to notice that the derivative of x to the 4th is x cubed, so we're going to use u substitution. U is equal to 1 plus x to the 4th, therefore du is equal to 4x cubed dx, taking the differential. And we want dx then equal to, good. Now we're going to rewrite our integral to be in terms of u. So integral, I'm going to put the bounds of integration on in a second. We have x cubed, 1 plus x to the 4th turns into u cubed. Dx becomes du over 4x cubed. What happens to the x cubes? They cancel, and that's how we know u substitution works. We also want to change our bounds of integration, remembering this is a definite integral, which means we do need a numerical answer. To find our new bounds, we're plugging into our u substitution. So negative 1 to the 4th is 1. 1 plus 1 is 2. 1 to the 4th is 1 plus 1, which is 2. So we can rewrite this. Our constant can go to the front. So 1/4 the integral of 2 to 2 of u cubed du. At that point, we can either integrate or we can recognize that if we integrate from c to c, the answer is 0. Letter C, we want to integrate from 4 to 5, 1 over x minus 3. Because that's a quantity, again, we're going to use u substitution. So what are we going to make u? As x minus 3. Therefore, du is equal to dx. 1 dx, which is just dx. Therefore, we're going to change our integration. Change our bounds by subtracting by 3. 4 minus 3 is 1. 5 minus 3 is 2. Now we're integrating 1 over u du. So we changed our variable. Now we can integrate, and we should know by now that that integral is ln of u plus c, and we're going to evaluate that from 1 to 2. So that's ln of 2 plus c minus ln of 1 minus c. C's cancel. What's ln of 1? That's 0. Therefore, our answer is natural log of 2. Letter D, we're integrating from 0 to pi halves, cosine to the 4th x, sine of x dx. How are we going to do this? We're going to recognize that the derivative of cosine is sine. So we want u to be cosine of x. So du is, derivative of the cosine is negative sine of x dx. Therefore, dx is du over negative sine of x. Now we can rewrite this in terms of u. So we have the integral using our u substitution. Cosine of 0 is 1. Cosine of pi thirds is 60. Cosine of 60 is 1/2. If you get stuck, you can check that on your or calculator, making sure you're in degrees. Radians, sorry, radians. That gives us cosine of 4x becomes u to the 4th times sine of x dx becomes du over negative sine of x. What cancels? The negatives. That gives us the negative integral from 1 to 1/2 u to the 4th du. Here we can use a trick. What's the negative trick? If we flip the bounds of integration, that makes our integral negative, and so what will the two negatives do? Cancel, be positive. So 1/2 to 1 u to the 4th du. Just less negatives to worry about. That is 1/2 times u to the 5th over 5 plus c evaluated at 1/2 and 1. We write that one more time as u to the 5th over 10 plus c evaluated at 1/2.
Hey, lunch report back in 3 hours.
That's going to be 1/10.
Why did you say number 5? Or you can do
I don't know where I got the 1/2. I was plugging in the valuation. Sorry. That gives us 1/5 plus c minus that 1/60th minus c, and that gets us, do that on the calculator, 31 1/60. Questions? Letter E, what are we going to do here? Well, if we take the derivative of x to the 4th, that gives us our x cubed. So I'm going to set u equal to x to the 4th plus 9. Therefore, du is equal to 4x cubed dx. So now we are integrating. Change of bounds, plug in the 0 is 0 plus 9, which is 9. 1 to the 4th is 1 plus 9 is 10. And we have 1 over, well, we have x cubed over the square root of u. Dx then becomes du over 4x cubed. X cubes cancel. So now we're integrating from 9 to 10. I'm going to pull the 1/4 out to the front. That gives us a u to the negative 1/2 du. Questions to that point? That means we're going to evaluate. We have 1/4 times. Add 1 is be u to the 1/2. And then we have to divide by that. Divide by 1/2 is to multiply by 2 plus c, and we're evaluating that for 9 and 10. So So that gives us 1/4 times 2. Remember, this is square root, so 2 times the square root of 10 plus c minus 2 times the square root of 9. Square root of 9 is 3, so that's minus 6 minus c, cancels. Multiply by 4, so 2 over 4 is 1/2 root 10. So root 10 over 2 minus 1/4 of 6 would be minus 3/2. If you did that on your calculator, then this should be 0.081. Again, using whatever answer notation your college professor wants you to use on that one. Questions, Skip?
So how did you get the negative?
How do I get the negative?
Yeah, like, right, go to the right and then up. Is that a negative 1/4 or is that just 1/4?
That's 1/4. That was an equal sign with a fraction board.
So, okay, what did you do? So u equals -1/2 and then you got 2u1/2.
We have to divide by 1/2, but
Okay.
that's our exponent.
Okay.
And then I flipped and multiplied. That became times 2.
Wait, so you divided what by what? You added 1 and then divided by 1/2?
Yes.
Yeah.
So this was 1/4 times u to the 1/2 divided by 1/2 plus c. So I flipped that 1/2 and multiplied by 2. Other questions? Integration by parts. Here we're using Lipit. L is logarithms. I is inverses. P is polynomials. E is exponent. T is trig functions. Therefore, what we want to be u, 5x, that means dv has to be sine of x dx. U, we're going to differentiate, finding the differential. Derivative of u is 1 du. The derivative of 5x is 5 dx. The dv we want to integrate. Integral of the differential dv is v. Integral of sine is, careful, negative cosine of x. Formula for integration by parts is, goes in alphabetical order, uv minus, flip it, v du. Therefore, we have u is 5x, v is negative cosine of x, minus the integral v, which is a negative cosine that makes this negative positive, cosine of x du, which is 5 dx. Now we want to integrate that second part, so we get negative 5x cosine x. The 5 actually comes to the front, so the antiderivative of cosine again is sine, so plus 5 sine of x, and as always, plus c.
And you'll tell us what.
That's a good question. Ask me that when we're done.
Okay.
Letter G, tabular method. Tabular method, again, we want to set up u. We want to set up dv, and we also need the sine. What's u going to be? Lipit is 2x squared. dv then is cosine of 3x, which sine starts with plus.
Please remember not to pass from the 99 wing to the cafeteria to the courtyard. Those doors are locked. And B1 and B3 are released to lunch.
So we're going to differentiate u till we get to 0. Derivative of 2x squared is 4x 4, and 0. We're going to integrate cosine. So what was the derivative that would give us cosine going backwards is, right? So the derivative of sine is cosine. So we want sine of 3x, but we have to take into account the chain rules. We have to put a 1/3 or divide by 3. Antiderivative of sine is negative cosine of 3x. Now we have not a 1/3, but a 1/9. And now we have a negative sine of 3x times another 1/3 is 127. And we're doing tic-tac-toe. So a positive 2x squared times a 1/3 sine x is a 2/3 x squared sine of 3x. A 4 times a negative 4x times a negative 1/9 is a positive 4/9 x cosine 3x. And a positive 4 times a negative 1/27 is a negative 4/27 sine of 3x. As always, plus. Questions?
Which was like on. So I have someone to feel like divide it by. whatever
B2,
the,
your release privilege.
Antiderivative, that makes sense to me, but then like on the one right above it, how like we had like the 5 and we didn't have to divide it, is it because it's not like with the x?
Yes, here there's a 1 in the argument. Here there's a number 8, there's a 3 in the argument.
Okay.
So if there's a 3 in the argument, we're dividing. If there was a divided number in the argument, then you'd have to multiply.
But if that 3 like right there, which would have been like in front of it or something, then you wouldn't have to worry about it.
Correct. Right, and the easy check is to take the derivative. Derivative of this, 3 sine of x, would be cosine 3x, and you have to multiply by 3, and that takes our negative 1/27 back to 1/9, which is why I have to divide by 3 in the first place. Marley?
On the integration by parts, how do you know when to stop? Because like, why didn't you do
Once
cosine of x?
Once the second one integrates, then you're done. The reason that we use tabular method is because this one didn't integrate. You had to use integration by parts again. So you had to keep repeating the part. We call that repeated integration by parts. So this was just a 1 step.
So if it says.
If we had to do this one with integration by parts, we would have had to do it 4 times.
Yeah.
So when that last integral integrates without having to use U substitution, you're done. Integrate using separation of variables. So we want the y's to be on one side, the x's on the other. We can do that by just simple cross products. That gives us y squared dy equals cosine x dx. Now we can integrate the whole thing. And that gives us a y cubed over 3. Integrate cosine x is sine of x. We want to solve for y. That gives us y cubed equals 3 sine of x. Therefore, y is equal to cubed root of 3 sine of x. And as always, plus. Two more to go. Questions that page? Integrate using partial fraction or fractional decomposition, if you want to use fancy words. So what are we going to know? This one's already factored for us, which is nice. This is a monster one. So what do we have? So we have x plus 1 times x minus 5 is going to equal something, x plus 1 with an a plus x minus 5 with a b. And that's going to equal to 4x cubed minus 69x minus 83. Therefore, we're going to use our crisscross smiley face. 4x cubed minus 69x minus 83 is equal to a times x minus 5 plus b times x minus 1. Again, that was our crisscross. Therefore, what does x have to be? X is either like 5 or 1 because we want those values to go to.
Zero.
It should be like.
Yeah.
I don't know that I want to post this to the internet. You guys are going to expose all of my teaching flaws.
It's okay, I mean, it's.
I'm only human. Here we go. If x is 5, then this one goes to 0. So we have b times 5 plus 1. That is 6b is equal to, we want to plug in 5 here. Does anybody have that? That is 72. Therefore, b has to be, we divide by 6, b is 12. We plug in -1, now we have -1 plus 1 is 0, so the b goes away. We have for the a, -1 minus 5 is -6a. Plug in -1 into our expression. And that is what you get. -18 is what I have. Usually these are going to be integers. Therefore, a is 3. So now we're not going to integrate that. We're going to integrate our new fractional decomposition. So the a is 3. So we have 3 over x plus 1 plus b, which is 12 over x minus 5 dx. And this turns into logarithm stuff. Therefore, we have 3 times right, plus c. We can simplify that. The coefficients become exponents. So this is ln of x plus 1 to the 3rd plus ln x minus 5 to the 12th plus c. If we are adding logarithms, we can multiply the arguments. This is ln of. This one has a cubic, so we have to make sure it is absolute value. X plus 1 cubed times x minus 5 to the 12th plus c.
Wish we had more like those.
Questions? Really?
Yeah, that's the
Seems,
third one.
okay. And finally, initial value problem. To do that, we're going to do what to both sides? Integrate both sides. That gives us y is equal to 7x to the 3rd over 3 minus plus c. Now our task is to figure out what that c value is. To do that, we're going to plug in our numbers. To do that, we're going to remember x is the inside number. That's the -1. Y is the output, which is 0. Therefore, we get 0 is equal to 7 times -1 cubed divided by 3 minus 6 times -1 squared divided by 2 plus 3 times -1 plus c. We're going to put that in our calculator, move it to the other side. Is what? You might have that. (25/3). Are we done?
No.
No, we need to.
Take it back.
Y is equal to 7/3 x cubed. This one simplifies minus 3x squared plus 3x plus 25/3. Just a quick preview of what we didn't get to. Find the area bounded by two curves. Right, here's the shortcut idea. So we have one curve and then we have another curve. Now we want to find the area between them. How do you do that? Well, really, it's just two integrals. We're going to find the integral of the first, x squared minus 3 dx. And then we want to take away this area because we counted it twice, which is just minus the integral of the second. So that's how that would work. We didn't get to that. We didn't get to revolving axis. Question, final exam.
19, 20, and 21 are on it, right?
Correct.
Will you tell us what method to use for integration?
Good question. Let me pause our video. Have a good day, Maroons.
Yes.